Good afternoon, everybody. My name is Derek Kwan, and today we'll be giving you our presentation on the misconceptions of physics in Hollywood media. Well, today we'll be embarking on a journey into the wonderful world of media and its inaccurate presentation of physics. From movies as visually stunning as Marvel's Avengers to the idea of a tornado full of sharks. Bad physics is found in a myriad of Hollywood's worst and most beloved films. The movie we'll be observing is the 2010 film, The A-Team, which has a premise that revolves around a group of 4 elite operatives who are framed for a crime that they didn't commit. As wanted criminals, the group sets out to prove themselves innocent. Now, it's no Casablanca, but The A-Team is an action-packed film that is filled with over-the-top physics that Hollywood is notorious for producing. The concept being misrepresented is forces and gravity. Now, the team find themselves in a free-falling tank that's attached to a torn parachute, and in order to land safely, the team tries to fire the tank to decelerate their descent before crashing into a lake.
Hi guys, my name is Ryoto. In the scene, we saw that the tank was propelled upwards by the force of the cannonball alone. According to what we know about the physics, this just isn't possible. Let's draw out a theoretical free body diagram of what's happening and map out isolated reference frame. We consider the tank, parachute, and Earth as the object in the frame and only observe 2 moments in the tank's descent, when it reaches terminal speed and when the cannon actually fires. Before firing, the tank actually fell down for a while, so we assume that the tank reached terminal speed, and there are two forces acting upon it: the force of gravity and air resistance. The moment that cannon fires, the force of the cannon acts against the force of gravity and added like so. Despite the force of the cannonball acting against the force of gravity, the sum of the forces in the negative y direction isn't enough to be greater than the gravitational force. How do you butcher science again?
So what we're describing is a concept that all of us are familiar with: forces. Because the tank is in free fall, we'll be neglecting the sum of the forces in the x direction, because they fire the cannon in the x direction to change direction, not to decelerate. Therefore, we'll only be considering the forces in the y component. As Ryoto mentioned before, there are a total of 3 forces we'll be observing: the force of gravity, air resistance, and the force of the cannonball. Now let me just write out the calculations and show you all. Done.
Sorry. The true calculations. To be able to move the tank upwards, the force of gravity must be less than force of cannonball. The force of gravity on the tank described as the mass of tank times the acceleration due to the gravity. The force of cannonball described as the mass of cannonball times acceleration of cannonball. According to Google, it has a total mass of 20,184 kilograms. Fires ammo that has a mass of about 10 kilograms per round, and fires at a velocity of 122 meters per second squared. We find that the total force of gravity of the tank is 197,803 newtons, and the force of the cannonball is just 1,220 newtons. So according to our math calculations, it is impossible that the tank move upwards by the force of the cannonball exerted on the tank. So what should have happened in the scene is because the total force of the gravity on the tank was so much greater than the force of the cannonball, the tank should just kept falling instead of moving upwards when the cannon was fired.